So, folks, we're going to hold on a second as people come in. Um, there seems to be a problem with YouTube putting the wrong time zone on this. Back in a second. I'm going to run to the bathroom as we're waiting for people to come on, and we'll get started with the questions. Okay. So I've had back-to-back meetings today. Haven't had much time to get prepared for this session, but I was looking at the questions ahead of time. Let's look at what we have with Piazza. So, Haresh says, I'm trying to apply the concept that I've learned in this course, but there are very few libraries on, say, automated planning. Do we kind of have to have access to journals to find algorithms to code, to debug by hand? If we want to apply our knowledge, how would you do it? Well, in this field, there are several important journals. One is the AI journal that's actually published by AAAI. And that's where some of the papers that we have for your required readings and your additional readings come from. There's also the Journal for Artificial Intelligence Research, or JAIR. That's a good place to get it. So a lot of times to see the state of the art as far as the algorithms, you get the papers. A lot of times these days in AI research, when a paper comes out, you have a new algorithm like at NIPS, NIPS, or now it's NeurIPS, NEURIPS. That's where all the neural net stuff goes. There is they encourage you to actually include your code on your website with your data and everything else. So these days with AI and algorithms, it's a whole lot easier because people are encouraged to actually put out their code and their data sets. This is something, if you look at the face recognition stuff, the eigenfaces stuff we talked about office hours a couple weeks ago. And I was doing all the stuff on the whiteboard and showing about compression and transmitting the presence image to the moon and this sort of thing. That code still exists, I believe, I think I put it out in 1991, maybe. I think it's still on whitechapel.me.mit.edu. And you can see code. You can find the original papers too. But of course, these days, the standard algorithms are, in lots of toolkits. MATLAB often has it. SciPy, NumPy. A lot of these toolkits have the standard algorithms. Now, for planning is still a relatively niche field, and so and the progress there has been slower than this sudden rush in neural nets, and that for planning, I think the book does a decent job on graph plan, and once you get past this course, I won't suggest doing it now, clearly. Once you get past the course, a lot of the algorithms the books talk about are now in the upcoming edition of the book, the 4th edition of the book. They have a lot of the algorithms actually coded up in Python ready to go for you. And this is one of the reasons why we explicitly talked about that, trying to avoid the plagiarism thing, because we hadn't realized the 4th edition book had so much code in it. So if you're looking for some of the stuff, the code's already there. Russell and Norvig do a really good job, and we try to help them out. The other AI professors try to help them out in providing code or resources. It just makes it hard to make interesting coding assignments. So yeah, if you're looking for stuff from the class, look at the 4th edition of the book, code after you've done your assignments. And if you're looking for more state-of-the-art stuff, a lot of times in NeurIPS or AAAI or Journal of Artificial Intelligence Research or Journal of Machine Learning Research, or any of these things, often the paper will give you pointers to code and data sets. In fact, that's one of the ways to get famous, get a lot of citations, is provide an interesting set of data for an interesting problem with a first pass at it with a good algorithm. Okay, so I'm going to mark that as resolved. I'd like to know more about discuss pattern recognition in general. Let's see. This is John. Oops, I'm losing my hitting the wrong keys on Piazza here. I'd like to know more about discuss pattern recognition in general. Great. The bonus in assignment 6 got me thinking a lot about patterns in general and data streams of data. John sees where I'm going with my assignment. What if we didn't know Morse code? What if we're given a stream of ones and zeros and asked to find arbitrary patterns in the data? I assume this is one of the great unsolved problems in AI, but how far along have we come to solving this problem? Okay, John, thank you for asking. Where I've been going with assignment 6 for years, I'm still not quite there yet, is trying to actually get to where you're actually doing pattern discovery. So if you go to, look in the chat here, if you go to smarttech.tech.edu there, and look for David Minin, who's my PhD student, you'll find something on pattern discovery. And the student who worked on it after him is Daniel Kohlsdorf, who actually helped me write a lot of the original assignments for this course. Both of those dissertations, like you can go to smarttech.tech.edu and click on dissertations, type in David Minin, type in Daniel Kohlsdorf, you get the dissertation, and you'll figure out a way to actually, without knowing Morse code, discover Morse code. And so what David did is we started out with just exercise routines, and you can see I'm getting all excited about this because this is my happy place for the more theoretical stuff we're doing, and so I get all excited about it. The goal here is just to give raw data from anything, from speech, from OCR, just a stream of pixels, audio, video, whatever you have, and be able to have one algorithm to rule them all. One algorithm that actually does a decent job of looking at repeated phrases through time, so to speak. And we often call those repeated phrases motifs. At least that's what the literature seems to have settled on. I don't particularly like the name, but you go with what's out there. And so the first thing we did that was really successful was we put an accelerometer and gyro on the wrist. Now, this is back when these smartwatches didn't exist yet. These sensors were really crappy, but we actually had a wired sensor. And David would go into his exercise routines in the gym, and he did 32 different instances of exercise routines. He did 4 different exercise routines in general. So where he mixed up the exercises. He did 6 different exercises as part of the routine, like things like bicep curls and Arnold presses and this sort of stuff. Bonus points if you know what an Arnold press is. And the rowing. And so then he just took that data. Each stream was like a half hour or something like this, and just threw it at his algorithm, and which we should probably have a good name for, and try these different algorithms. And he could actually get his best algorithm could actually get a stream out first tokens. He would discretize it first. Then he'd look at those combination of tokens, and his system would actually hypothesize different motifs. And those motifs, actually, he ended up getting, I think, all 6 motifs, all 6 exercises. Plus, he got something like wiping his forehead or something, if I remember right. And so the system actually got not only just labeled them, motif 1, 2, 3, 4, 5, 6, 7, right? It then labeled the data where those things were, and it was precisely correct. It identified that there are 6 different exercises and labeled them correctly 97% of the time. 6 in the future is actually give y'all a Morse code, a new version of Morse code, and show you how to actually do discovery using the techniques that David had invented. Okay, so I froze. It's the Wi-Fi. Hopefully, I'm back. Things seem to look good on my side, so I'm going to continue going. So let's see here. Streams of ones, zeros and ones are the 1D case. If we solve this problem, does it mean we solve the 2D case? Confiders and pattern images for image recognition. The more dimensions you have, the harder it gets, because what happens in pattern discovery is that some dimensions are informative and some dimensions are not. What's cool about the David's dissertation is part of his dissertation says, I am going to learn which dimensions to ignore in doing my pattern discovery. So that's very observant of you, John. There's something like assignment 6 bonus, but where I can work collaboratively, may an open source project about pattern recognition in general. Well, this is actually my honest to God research. You can see this sort of stuff in Daniel Kohlsdorf's dissertation. What we're currently working on is dolphin vocalizations. We are discovering fundamental units in their communication patterns and then trying to basically see if they actually have identifiable words for things. They said that dolphins actually have individual signature whistles. We talk about that in the videos. But beyond that, do they have a word for seaweed? Do they have a word for Denise, my partner in this? Do they have a word for boat or eel or whatever else? And so that's what we're applying our algorithms to. And so, we always used to laugh that, if ever there's a species that wants to establish communication with us, we have some of the few algorithms in the world that actually can handle that. And so we're hoping to encourage the dolphins to actually provide enough evidence of potential words. So far, no breakthrough. We do actually have particular vocalizations associated with particular types of social gatherings or social behavior they do. That's the output of Daniel Kohlsdorf's dissertation. Feel free to read it. It's kind of cool stuff. That's the state of the art. And this is a very niche area in AI right now. A lot of people get excited about unsupervised learning in the beginning, but they give up because it's so hard. We've been actually making slow, steady progress for about a decade now. All right. I'm approaching the end of my OSSES degree and wish to continue my education on this topic. A PhD is out of my budget. That's not true. I know pattern recognition is your specialty. Do you have any advice on how to learn more on this topic of pattern recognition classification? Right. So, first of all, what most people might not realize about a PhD in CS or any of these other well-funded fields is we pay you to do your PhD. We don't pay you much unless you happen to be in Europe or Australia, but Germany is particularly good to get your PhD in, or any of the Germanic states. But oftentimes professors have grants that they're working on. They need people to work on the details of those grants. And so most high-end PhDs in CS, once you get admitted, the program finds money for you to get through the program, so you get a stipend. In Europe, it tends to be actually decent stipend, like $50,000, $60,000 a year. In the U.S., it tends to be just above food stamp level. So we're talking about under 30K, maybe 26, 27, 28K a year. If it is possible to go and get your PhD, not only the tuition, everything paid for, but also get paid to do it because you're doing work, and hopefully your research and your pay for research and your interests align. Now, if you don't want to do the PhD, which I completely understand not wanting to do, there's lots of things out there. Now, the big thing is actually working with a master on a project. So I talked about, you saw the Jack Watson stuff that Rocco sent out on the list. We also have the Parker system, which some of you are using. All these are projects that you can get some background in. And so basically what you want is somebody like Charles Isbell or Frank Dellert or Tucker Balch or Seth Hutchinson or one of these machine learning. Byron Boots is great. Any of these guys who actually do this stuff as part of the daily life, as part of the daily research, volunteer to an 8903, do research with them, so you get get somebody interested in you and doing the work in that space. That's how you really get a deep knowledge. This is actually doing a real project with a master on it. And there's lots of things in AI. It's as you saw in this course, there's lots of stuff. One of the on-campus students right now has just actually done picked up the tri-directional search problem from assignment 2, and is actually going to write that up, we hope, for a publication coming up here shortly. He's actually discovered some interesting stuff we'll share with you, hopefully after final. John is asking, how do I get started on that process, getting my PhD paid for? John, all you have to do is get in. So apply to the PhD program, say here, or at CMU or MIT or University of Washington, any of these places. Any of the top places. If you get accepted, they generally have a guarantee of funding, at least for the first year. And if you make progress on your dissertation, generally the PhD programs take care of you and make sure you get funded until you get out. As long as you actually find a professor whose work matches up with you, this sort of thing. It is possible to actually go and be self-funded, but almost all PhD students either end up doing a graduate research assistantship for their entire PhD career, or do a TA-ship for at least part of it, or get a National Science Foundation or some sort of foundation grant, which pays for their way through it. Very few people can afford a 5-year PhD without getting some sort of funding. Okay. So it's freezing occasionally. My apologies. I don't know if it's going to the servers and coming back or not, but I seem to still be okay here, so I'm going to assume I'm still good. Okay, the next question is, John has included the dissertation I was talking about. Let me put into, there you go. Okay, so this is Ah, in Kaggle competition, my ADA boost stayed around 91%. I just missed by a bit. Is there a possibility to lower the threshold to around 90% or so? No. I don't know. The TAs are running all that. I have no idea how they're handling the Kaggle competition this time. Um, so if you that's something to ask the TAs on about. Just helping out with the research. I live in Atlanta, not too far from campus. My office hours are 4 to 6 on Wednesdays. It's on my website. Let's see. I will be around next week. Perhaps you can come in during that time and talk. Send me a resume so that I can see what your background and see if there's any matching up with our current projects. Last semester, I believe that between Jack Watson and Parker, I had half of the 8903s, half of the independent studies done with OMSCS, if you can imagine that. So we're still trying to figure, doing research with the online students is still a relatively new thing. I think you guys have great potential for doing research with us. The question, but it just takes a little bit more effort on our side to figure out how to structure it. Now, the great thing is that I found out that a lot of you out there are already program managers or project leads, tech leads in your own companies already, and you know how to organize folks. So what I found, and a lot of you are actually, got industry experience, know how to make projects. So I've been advocating for us to put together a more formal independent studies 8903 program together. You can take 8903s as often as you want. It's great for your GPA if you love the work. But I really am looking at how we can structure independent research for the online students, because that's how I think you actually really learn this stuff. And how do we make it scale? Now, there's some problems, especially in AI, that scale very well, because you can actually do the same problem and just shard it into different teams, and either parts of the problem or the same problem, and just have people running in parallel and see what the results come out on. Why not? And this would be especially good if those of you who are taking the class right now, you could imagine get some research and get trained up on how to do the research, and then have your own researchers, your own teams online. And I think that OMSCS has a lot of potential for doing interesting research, especially in this space, especially now at the stage that a lot of the stuff just needs collecting new databases, playing with this stuff. Some of you all have actually transitioned from online to on campus. And that's been especially useful for us because allows us to actually think more about to work with you on a one-by-one basis, to actually think about moving, how do we involve the online students in research. I could imagine something where we end up getting some of you all for PhDs, and part of the research or part of the teaching is figuring out how to organize online researchers. So, I'm quite, if I wasn't so busy right now, I'd probably be working much harder on trying to get you all into research teams going forward. If you're interested in this sort of stuff, look at the VIP projects on campus. It's a mixture of everything from PhD students and professors down to freshmen. What if we actually get OMSCS involved in the VIP projects? These are generally multi-year projects and extremely interesting stuff. So I think there's going to be more opportunities coming forward in the future, but we're not organized yet. As a matter of fact, I'm going to be talking to the dean, to Z, and to David White, David Joyner, about this stuff next Tuesday. So the VIP projects, generally there is a presentation of them. I don't know where they're kept offhand. I have not done one yet, though I do things that look very similar using the undergraduate research program, and the master's 8903s, the master's independent research. I do not know what a list of VIP projects. It's called it's vertically integrated project. You can probably find some examples online if you just search for, a VIP. Maybe if you do VIP or vertically integrated project site gatech.edu on Google, and that should hopefully get you something. And I don't know where you actually find the open ones online, because this is a new framework that I've not really taken advantage of yet. I'm still trying to get 8903s working. Okay, so let me see if I have other questions here. I guess I need to refresh Piazza. I should talk about the final a little bit. No new stuff on Piazza. So, final exam. This is one of the longest final exams we made in pages, I think, ever, because we're actually teaching you guys new things in the final exam. I'm not saying it's any harder or any longer. I'm just saying it's a thick book of paper, so don't get scared by that. However, please plan your time next week to know that you guys have already done the midterm, you know how long it takes. Midterm is a little easier than normal for this course. This final exam, I don't say it's any harder or any easier. I think it's about average in that. I think it's much more interesting than most of the final exams we do. But it is a lot of pages. So please, when you actually do the final exam, please make sure to that you use Grayscope and all that carefully, and try to please keep the pages in order. Grading this thing's going to be a bear, but I really enjoyed. I had my TAs teach me stuff from their domains. How they do things. We're going to show you actually some real practical applications of stuff you've learned in this course in the final exam. I'm actually quite excited about the final exam. Like I said, I learned stuff. I thought it was fun. Hopefully you guys will find it to be the case as well. And I think it took I think we have 11 TAs, and we all spent about 10 hours together working on it, proofreading everybody else, just in a group. Everybody proofs every question and works on every question. So hopefully got a lot of the bugs out. There's always going to be some bugs, but that's the price of doing new questions. But and also everybody did the everybody try to get the English and stuff correct and try to take out misinterpretations. But please schedule the time for the final exam. Give yourself enough time, especially please, after you upload it, make sure it is uploaded properly. Make sure your answers are actually saved. It actually shows up. We've had a couple situations where people upload, especially on a Mac for some reason, where people uploaded it and the answers disappeared. Make sure after you upload it on Gradescope and Canvas that the answers are actually there afterwards. Otherwise, you might be very unhappy, and will be very unhappy. Did I answer about pattern recognition outside of a PhD? Yes, I did. Anything more about that? You all should now have enough knowledge to really be able to read some of these books. I will show you some of the books actually. Like I said, the biggest thing is actually working with the master and doing a real problem so we see what the real issues are. But how I pick up a new topic is often I get a book on it or I read the papers. Let me show you some of my favorite books. Let me be right back. I gotta grab them from my shelf. Okay. This is, if you want to know more about HMMs, this you can download off the web. It's Entropic's HTK. This is Hidden Marker Model Toolkit. It comes out of Cambridge University. This is basically a user's guide to their toolkit. In the first few chapters, there's a really good description of what's going on. For a modern HMM implementation, it is I think a really good introduction. What's this about the Coke? It's that bottle of the Coke, the first one of its kind. But this bottle here, I don't even remember why this is here, to tell you the truth. I have no clue. I do have one of the 100th anniversary Coke bottles, which is like gold. It should be here somewhere. But okay, so someone was asking about this. The title, please. Yeah, this is just the it's just HGK Hidden Marker Model Toolkit. There you go. And the other thing is look for my PhD dissertation if you want to, or my master's. There's two different explanations of HMMs in those two things. However, you're getting it mostly from the videos from me anyways. So like I said, I'd use this instead. This is often what I used to teach from. This is pattern classification from Duda, Hart, and Stork. Here you go. This has some great stuff. I particularly love, let's see if I can find it, particularly love some of the illustrations in this book, where it's actually showing maximum likelihood images. Matter of fact, some that you see in my lectures were inspired by this book. So even just like the second chapter here, I find to be by some good intuition. Now it does lots and lots of things in here. Talks about back feed forward networks, all that type of stuff. And one of the things you should realize is that there are lots of ways to describe this stuff, and we are always trying to improve our descriptions. So if all of us, all the professors have many different authors' books, and we always look through them to figure out which explanation speaks to us. And so my suggestion is, get a selection of these books, and if you don't understand the explanation in one book, go for another. Along those lines, here is Judea Pearl's book called Causality. Judea Pearl was one of the guys who actually is known for his books and his explanations. So a lot of people keep this around. There is the cover and Thomas. Okay, so you really need to know the names more than anything else. So Judea Pearl's Causality. I think this may not be his big book. This may be one of the more recent ones that I got. Because it was interesting. But all you gotta do is go look at Amazon, look up Judea Pearl, see his most famous book, and it's generally something you see people keep around. There's also cover and Thomas. I see a copy here, so I don't remember what the title is called. I think it's just not information theory. Can't remember right now. If you're interested in speech, that book, the author's name is Jarafsky. Speech and language processing is this one. I've actually read through this, but a lot of people swear by it. It kind of takes you through kind of the way I'm taking you through Morse code to learn HMMs. It kind of does the same sort of thing with speech. But of course, also the HTK manual does a pretty good job with speech. Here is the Forsyth book on computer vision. So Forsyth and Ponce. This, let's see if I can actually find this. It used to be my sign language work was in here. Let's see if it still is. So stuff you're doing for assignment 6. Oh no, it's not listed. Yeah, it used to be the stuff you're doing for assignment 6 was actually talked about as research in this book, at least in the first edition. I don't know if it's still here or not. Oh. And I was talking about eigenfaces. Here's the thing, doing that with image classification. So some of the stuff I hinted about in our office hours, or you see on the midterm or the final, where we kind of hint about, computer vision applications of that. You can see the more industrial version of it in these books. So this is a good one. This is a good one to get started on. Be right back. There's a couple other ones that I think you guys should see if you're interested in this. Yeah. Almost all AI professors will also have a copy of Tom Mitchell's Machine Learning. I believe he has a new copy of this coming out, or has come out. I would also highly recommend the 4th edition of Russell and Norvig. It's coming out. It should have a lot of the most modern approaches on it. And also, just to get other perspective, I've pointed you guys to Patrick Henry Winston at MIT. He's the one who taught AI to me. He's still teaching up there. His lectures on MIT's open coursework. His book is an easy read. It actually talks about a lot of stuff we talk about in this course, including some simple computer vision. He's actually kind of does a survey of the field. It is the Sussman anomaly, a lot of stuff that we've talked about. And even now, this I got, this version of it was 1984. This is an ancient book. There's a new, more modern version of it, but what's great is that some of these techniques still work. And if you're having trouble understanding stuff, this is a pretty easy read. I think that's it as far as the books I can grab off my shelf offhand. What I've been reading most recently is Kevin Murphy's has a machine learning book. I think it's called Machine Learning. But look for Kevin Murphy. He has a recent book, and I've gone through the first chapter because I was thinking about using some of it for this class, and I really liked the first few chapters on it. And if you're interested in the deep learning stuff, where's my Bengio book? Let me find where I put this. But Bengio has a good book that kind of reviews all the neural net stuff from the early ages to the most recent stuff that's sort of state of the art as of like last year. Um, uh, and that's I'll say it's the easiest introduction. But you guys, if you understood the back propagation in the book, in the Russell Norvig book, you'll have no trouble with this either. Okay. Well, let me see if there's any other questions. Oh. Okay. So you want me to type the book titles? Mostly it's these authors. Thank you, John, for adding it in there. Let's see, any other questions? Nope. Yep. Nothing else. Oh, let me reload Piazza just in case. And for those of you who are in striking distance of campus, 9:30 on Tuesday, we're going to have kind of review of the more researchy sections of this course. At least this is the first time I'm trying this. We'll see how it goes. We're going to have a review of how Parker's been performing and the algorithms it uses. We're going to have a review of what we've discovered on tri-directional search. There's some new research there that was done by Trace. We're going to have, we're going to show some of the uses of assignment 5 for eye tracking. That was done by one of my PhD students. We'll probably talk a little bit about the dolphin work and relaying that back to assignment 6 and stuff we talked about today. And basically kind of showing how the stuff really, and a little bit about Jack Watson, how Moss works, the anti-plagiarism stuff. So if you got a chance to come to class on Tuesday, it's 9:30. It's 801 Atlantic building. It's the basement, lecture hall 016. I'm hoping to have some fun and actually just go over the more researchy parts of this class. Okay. Nope, I might have got more stuff here. Great. I will talk with you guys later. I'm sorry I do not have the title of the Bengio book. I think you just go to AMP Deep Learning and Bengio, you'll find it. I can probably do that for you real quick. Bengio, Deep Learning. Yeah, Deep Learning. Yeah, it's just called Bengio. It's I can type it here for you. Deep Learning, Goodfellow, Bengio, and I can't remember who the first author is. Corville. Okay, and that's the book I've been reviewing to review my knowledge of how the neural net stuff works. Matter of fact, one of the things I really like to do is have a deep learning section in this AI course, but I figure a lot of you guys are going to take the deep learning course anyways, or the machine learning course, get some of it there. Okay, I was hoping to do some OCR stuff today, but ran out of time because I got all excited about the pattern discovery stuff. One of the things, if people are interested, one of the things that I also sometimes sponsor students to do on OMSCS is help me make better problem sets, right? Especially assignment 6. I really want to get that. I really want to take the Morse code one that you guys have online and potentially the sign language one that the on-campus students are using this time. I'm trying out 2 different directions of how to teach this stuff. I think I might combine them at some point. I'm not sure how to teach in a contained assignment, but that's something else I'd be very interested in having somebody help me with. So far, I've gotten some very good success. Some of the students here said they didn't really understand some of the finer points of HMMs and discovery until they actually did that homework assignment. So I'm feeling good about it, but still not where I want to be. All right. Thank you very much, guys. Good luck on the final, and hopefully I'll get some time to talk with you afterwards and have some play. All right. Have fun.